25 million years ago, Australia was covered in wet forests, dominated by orthophagous plants, like these myrtle beech. As the continent moved northward, the climate became drier, and with it the wet forests of ancient Australia retreated. But as the orthophagous began to decline, other plants stepped forward to greet the sunlight. Of these new contenders, one group in particular would rise to dominate the Australian landscape for ages to come. The eucalypts. Australia. A lonely giant straddled by 3 oceans. Its wave-battered shores, a testament to an ancient isolation. Growing from its soils, the quintessential Australian tree. Eucalypts dominate almost every habitat on this giant island. Their iconic forms an inseparable part of the character of the Australian bush. But it wasn't always this way. Towards the end of the Cretaceous period, some 65 million years ago, Australia was a very different place. Its ancient shores were then fused with those of Antarctica and New Zealand in the great supercontinent of Gondwana. A warm, wet climate prevailed, and rainforests dominated the landscape. Yet amongst this strange, alien continent, a familiar sight.
Fossil evidence suggests that the eucalypts are quite old. But a few years ago there was an absolutely amazing discovery of superb fossils in Patagonia in South America. They're very well dated because of the volcanic ash, that they're 52 million years old, and they represent whole leaves and fruits. You can even see the oil glands in the leaves, so they are so superbly preserved. And they're undoubtedly in the genus Eucalyptus. And so the idea is that the eucalypts, the progenitors, the first eucalypts would have been distributed across eastern part of Gondwana, ranging from South America, probably in Antarctica, in the Australian continent, and even possibly to New Zealand. So while Australia was still connected to other parts of Gondwana, Antarctica for example, rainforest vegetation would have been dominant. And so I think the eucalypts were probably not very dominant, but they would have been sort of lurking around on those ridge tops, on the porous sites, the less fertile soils. And it was during post 40 million years ago, and probably in the last 15 to 20 million years ago, as climates changed, and there were a number of waves of climate change, that as Australia became more seasonal in its climate, we had periods of hot and drier weather, we had more fire, then the eucalypts were in their element, if you like. They were pre-adapted to expanding and taking over those niches that the rainforest once occupied and contracted.
Australia was undergoing a transformation. As it journeyed northwards, its climate changed, and the continent began to resemble the hot and dry land we know today. Already adapted to life on the edge, a hotter, drier, more fiery world was one in which eucalypts could excel.
The early eucalypts that were probably hanging around on those edges of rainforests would have had hard leaves. They're called sclerophyll. Sclero means hard, phyll means leaf. And so as the climate and conditions changed in Australia, they were perfectly pre-adapted to expanding into tougher environments. Because a hard leaf, for example, means that the plant won't wilt very easily during drought, unlike a rainforest plant that would lose a lot of moisture. Eucalypts also had woody fruit, and so that pre-adapted them to surviving things like fire. So the woody fruit protected the seed from being cooked by a bushfire. The hard leaves and the woody fruits are typical of many of the myrtaceous plants in Australia. That's the family Myrtaceae that the eucalypts belong to. But the eucalypts also have their very specific own adaptations. And two things that I would emphasise is, first of all, the flower buds are protected by little caps or opercula, and that would have protected the male and female parts of the flower. Rather than having a really showy set of petals and sepals, they have these opercula or little caps. But the other key feature I think that's really important is that eucalypts have many dormant buds. They have dormant buds beneath the bark on the stem, and if the crown of the tree gets damaged by drought or fire or insect attack, the plant can usually recover. Now, not all species, but the majority of eucalypts have these dormant buds, and they give rise to epicormic shoots. You will have seen in a fire where the trunk of a tree is very, very quickly covered by new leaves. So the plant can recover from damage fairly quickly. It doesn't have to reproduce from seed until, of course, it reaches an old age. The other area where there are these dormant buds are the lignotubers. So at the base of many species of eucalypt, you'll find a swelling called a lignotuber. It tends to get buried beneath the soil. Some people call it a mallee root, but it's actually it's stem tissue, and that's another site where you can get new shoots sprouting after damage. So I think these dormant buds, these epicormic shoots, are absolutely critical to the survival of eucalypts in harsher environments.
With their arsenal of unique adaptations, eucalypts were able to survive and prosper where other plants soon perished. Far from being destroyed by the increasing frequency of fires, the eucalypts were in fact liberated. And as they spread out over the continent, they themselves accelerated the transformation of the land. For they don't only survive fire, they encourage it. They do this by providing fuel. Eucalypts can shed up to half of their leaves each year. And many species are well known for adding their bark and even branches to the forest floor. Their leaves dry quickly, but decompose slowly. And they're full of flammable oils and waxes.
Eucalypts have a lot of oil in their leaves, and oil will make the plant more flammable, and so it influences the behaviour of the fire. Eucalypt vegetation will burn very quickly, it'll be volatile. A fire will tend to move through a eucalypt forest much quicker than some other kind of forest. Now, the heat of the fire affects the survival of plants, but if the fire goes through quickly, then there's less damage done.
Most adult eucalypts are left relatively unscathed by such fires. And in promoting them, they ensure the survival of their offspring by returning valuable nutrients to the soil and doing away with any competition. Some of the same traits that have enabled eucalypts to survive in a fire-prone continent have also allowed them to deal with Australia's infamous aridity. Lignotubers store water and nutrients, allowing trees like these mallee eucalypts to survive during periods of drought. Hard leaves act to conserve water and hang vertically to minimise their exposure to a harsh sun.
As the eucalypts became more and more dominant in Australia, they also diversified, and so today we have an enormous number of species. In the genus Eucalyptus, there are about 800 species. In the genus Corymbia, which are the bloodwoods and ghost gums and spotted gums, which is another group of eucalypts, there are about 100 species. And the third genus that we refer to as eucalypts are the Angophoras, or the apples, and there are about a dozen species of those.
Thanks to their ability to survive under harsh conditions, eucalypts have expanded into almost every type of environment Australia has to offer, forming everything from tall wet forests and open woodlands to sparse mallee scrub. Each new species a solution to a question posed by the Australian continent. Their diversity today signifying a myriad of strategies for survival in Australia's different environments.
Eucalypts in the broad sense inhabit a really wide range of environments, from the most arid conditions in the outback through to really high rainfall areas in Tasmania and Victoria. And they occur from the coast all the way up to the snow line. You know, they really are amazingly diverse in the environments that they inhabit. That doesn't occur in any other tree genus in the world. That range of environments that these species inhabit is pretty much unique. I think why we see the river red gum everywhere across the country is that it's adept at exploiting a habitat that is very widespread. On the side of riverbanks where there's access to ready water use. They've got good access to water throughout their life, and they have roots that are fairly deep that can extract that. So that's one reason it's found everywhere. But most plants, most eucalypts aren't like that. Most of them have very narrow ranges. If we think about the tallest flowering plant, that's the mountain ash, Eucalyptus regnans. And that is restricted to areas of southern Australia, the mainland and Tasmania, that are cool, that have high rainfall, that have deep productive soils. And they can achieve amazing heights. You know, the greatest heights of recorded plants of recorded gums at the moment are in about the 80 or 90 metre range. But in the past, there were mountain ashes that were greater than 100 metres tall. Now, you can only grow really tall in places where the productivity is high, and things that kill plants, like disturbances, fires, wind throw and the like, are relatively rare because it's going to take a long time to get very tall. So plants and trees that grow very tall are restricted to high productivity environments. If you go to the desert, by comparison, and you think about the mallees, the small eucalypts and the snappy gums that are found in desert gorges, they're very short. They may only achieve 2 to 4 metres in height, you know. They don't need to get tall. They're not reaching up for the sun. And it's perhaps a waste of their effort to grow very tall.
But height isn't the only thing that differs among eucalypts. Australia's varying environments have shaped different species in more subtle ways.
So there's a number of factors, a number of attributes of plants that are related to and affect where they occur. And some of them relate to a fast lifestyle versus a slow lifestyle. So plants might conserve their resources, or they might be profligate in use of them. And those things manifest themselves in things that we can measure on plants. And some of them are about the leaves that they grow, some are about the stems that they grow, and some of them are about the seeds that they make. And so in all of those different organs, plants face a resource allocation problem. They have limited resources and they choose to make organs to face the challenges that they have in the environment. So the leaves, the stems and the seeds from which seedlings germinate are three really important characteristics that are of importance to where eucalypts are in the wild. And so if we think about the leaves, they can make thick and dense leaves that last a long time but don't yield a fast rate of return on the investment of carbon and nitrogen. Or they can make really short-lived leaves that yield a high rate of return and allow them to grow quickly for a while, but they're always having to replace that leaf, that canopy. These are both eucalypts, so this one's from Eucalyptus polyanthemos and this is from Eucalyptus viminalis. And so they're part of the same genus, but look at the amazing difference in their leaves, in how broad they are and how the surface area. What you can't see so much is the fabric of it and how thick and dense they are. The size of the leaf, and especially the width, has a lot of importance for heat gain and heat shedding. Really big leaves heat up a lot in the day, which a tree might not want in really arid places. But really big leaves also lose a lot of heat overnight. So the way that they grow their leaves has large implications for their distribution. When we walk around in the bush, we see mature trees mostly. We might see some seedlings on the ground, but most of the time our eyes move to the mature trees. And that's perhaps not the most sensitive part of the life cycle. And so when we think about what factors are actually influencing or limiting a tree's distribution, the sensitive part of the life cycle, the regeneration niche, or when the seedlings are germinating, might be more important for us to look at. And when we think about seedlings, one of the things that differs a lot amongst eucalypt trees is the way they provision their seedlings. So the mother plant, the euc mother, is making an allocation decision of its reproductive effort. It's got a certain amount it can devote to reproduction, and it can choose to bundle all of that into a few big seeds that are well protected by heavy, thick fruits that are resistant to fire and to drying out, or it could make lots and lots of small seeds without much of a packed lunch, if you like. This is where the seeds are kept in the eucalypts. So they're tightly inside underneath that woody fruit, and in this one as well. And so you can see the fruits are different in size. They're going to be different in the thickness of the walls that might protect them from drying out or from burning. And it's likely that their seeds inside there differ in their size and mass. And that has huge implications for the success of the seedlings that grow up. Seedlings that grow from species that provision with very small seeds typically don't have very robust seedlings. They're really prone to the vagaries of the environment. They grow well when there's good conditions for growth, productive soils, abundant water resources. But for seedlings growing up under harsh conditions, like nutrient poor soils and sands, and under dry conditions, again, sands might drain quickly and there may be no water. Seedlings that have got a large packed lunch that come from a big seed are much better off.
More than 800 living species of eucalypt are proof of their endless ingenuity. Capable of surviving fire and drought, and prudent with their precious resources, they seem endlessly adaptable. As a group, eucalypts have revelled in the harsh conditions of this ancient land. Through miraculous adaptations and diverse strategies for survival, they have conquered our mountains and our deserts. Having come to dominate the Australian continent, they have changed it too. Each new day, countless lives revolve around the existence of these essential trees. As we will see, the life of a eucalypt can be as diverse and challenging as the history that has led them here.